In the hopeful years after World War II, the world looked to the skies for its next great leap. Aviation was a field of constant breathless progress. The jet engine had already shrunk the globe, turning week-long ocean voyages into day-long flights. But for the ambitious engineers and political leaders of the era, this was not nearly fast enough. The next frontier was clear, breaking the sound barrier not just for military pilots, but for ordinary passengers. The dream was simple yet profound. A business meeting across the Atlantic in the morning and dinner back home in the evening. This was the promise of supersonic transport, or SST. It was a vision of a future unbound by the old constraints of time and distance. This technological ambition did not exist in a vacuum. It was forged in the intense heat of the Cold War. United States, Soviet Union, their respective allies competed on every conceivable front. Building the world's first supersonic passenger jet was not merely an engineering challenge. It was a matter of immense national pride and a powerful symbol of technological prowess. From this crucible of competition, two magnificent and deeply flawed aircraft emerged. From the West, a partnership between Britain and France produced the Concorde. It was a project born of shared expertise, immense cost, and a desire to maintain Europe's prestige in the world of advanced aerospace. From the East, the Soviet Union's formidable Tupolev Design Bureau created the TU-144. This aircraft was a direct response to the Western effort, driven by the Kremlin's mandate to be first at all costs. The two planes would become forever linked, rivals in the sky and symbols of the ideologies that created them, their stories intertwined in a saga of speed, glory, and hard truths. At a glance, their silhouettes were strikingly similar, leading to whispers and accusations. Long, slender silhouettes, powerful engines, swept delta wings. They were designed to pierce the atmosphere at more than twice the speed of sound, flying at altitudes where the sky darkens to a deep indigo and the curve of the Earth becomes visible. But beneath this superficial resemblance lay profound differences in design philosophy, engineering choices, and the very pressures that shaped their development. The design of the Concorde was a masterclass in aerodynamic elegance, the result of more than a decade of painstaking research and collaboration. Its most distinctive feature was the wing. It was not a simple triangle, but a complex shape known as an ogival delta. The slender curving wing was a work of art and science. It was optimized to create lift at supersonic speeds, reducing drag, and it gave stable handling during slower flight takeoff landing. This dual-purpose excellence helped Concorde's remarkable performance across speeds. Another famous Concorde feature, the articulating nose. For supersonic streamlining, it needed a long, sharp nose cone, but that nose would block the pilot's view during takeoff and during landing. The solution, a hydraulic droop nose with multiple positions, fully lowered for taxiing, fully lowered for landing, partially raised after takeoff, then fully streamlined for high-speed cruise. That mechanism became one of Concorde's iconic signatures. The TU-144 shared the delta idea, but took a different, more expedient path. Early TU-144 prototypes used a classical pure delta wing, simpler to build but less aerodynamically refined than Concorde's ogival shape. That choice caused control and stability problems at low speeds. To fix this, Tupolev added small retractable canards near the cockpit. Canards would deploy for takeoff and deploy for landing. They improved lift and maneuverability. But they added weight, they added complexity, and they introduced extra systems that could fail. Later, TU-144 production models used a more sophisticated double delta wing. It was an attempt to capture some of Concorde's aerodynamic benefits. It showed Soviet engineers were learning and adapting, but also that earlier designs were less optimized. The TU-144 was visibly larger and heavier than Concorde. Designers had to meet different engine requirements and different structural philosophies. That led to a bulkier airframe. The size and weight differences hurt range and efficiency over its short life. At the heart of any supersonic aircraft are its engines, and here the differences between Concorde and the TU-144 were profound. Concorde was powered by 4 Rolls-Royce Snecma Olympus 593 turbojet engines. These were masterpieces of their time, capable of generating immense thrust. Crucially, they were designed to allow Concorde to supercruise, that is, to maintain its cruising speed of Mach 2.04 without the continuous use of afterburners. Afterburners, which inject raw fuel into the engine's exhaust, provide a massive power boost but consume fuel at an astonishing rate. By being able to cruise without them, Concorde achieved a far greater range and operational efficiency, making transatlantic flights a viable commercial proposition. The TU-144's engine story was more complicated and problematic. The initial production models were equipped with 4 Kuznetsov NK-144 turbofan engines. While powerful, these engines were far less efficient than the Olympus power plants. Critically, they required the continuous use of their afterburners to maintain supersonic cruise. This design choice had a devastating impact on the TU-144's performance. The enormous fuel consumption severely limited its range, making it incapable of flying the prestigious transatlantic routes that were Concorde's reason for being. Later, an improved version, the TU-144D, was fitted with more advanced Kolesov RD-3651 engines. The challenge of flying at twice the speed of sound is not just about power, it is also about heat. As an aircraft moves through the air at such speeds, friction causes its skin to heat up to temperatures that can weaken conventional materials. Concorde's designers tackled this by using a special aluminum alloy called AU2GN, developed to withstand the high temperatures experienced during sustained supersonic flight. The entire airframe was designed to expand by several inches in length due to this thermal effect. To manage the engine airflow, Concorde also featured incredibly complex computer-controlled engine air intakes. These intakes changed their internal geometry during flight to slow the incoming air from supersonic to subsonic speeds before it reached the engine compressors, a critical and highly sophisticated system. The TU-144 faced the same thermal challenges, but employed a different and, in some ways, more complex set of solutions. Its structure was also made of aluminum alloys, but the aircraft systems were notoriously more intricate and less reliable than Concorde's. For example, where Concorde used its fuel as a heat sink, pumping it through the airframe to help cool the skin, the TU-144 relied on a dedicated air conditioning system for both the cabin and critical equipment bays. This system was heavy, complex, and prone to malfunctions. Throughout the aircraft, there was a sense that an emphasis on raw power and expediency had taken precedence over the refinement and integration that characterized the Concorde project. You know, those underlying choices really shaped everything. The development of Concorde was a marathon, not a sprint. It was a joint venture between the British and French governments and their leading aerospace companies, a partnership that was often politically difficult but technologically thorough. The program stretched over more than a decade, involving countless hours of wind tunnel testing, material science research, and component validation. Engineers meticulously studied the effects of high-altitude radiation and the thermal stresses of repeated heating and cooling cycles on the airframe. No detail was considered too small. This slow, deliberate, and incredibly expensive approach aimed to identify and solve problems on the ground long before the aircraft ever carried a single paying passenger. The flight testing program for Concorde was equally extensive. 2 prototypes were built, followed by 2 pre-production aircraft, and then the full production models. These aircraft collectively flew thousands of hours of test flights. They flew routes around the world to test performance in different climates and to demonstrate the aircraft's capabilities to potential airline customers. The rise of the environmental movement in the late 1960s and the 1973 oil crisis introduced new headwinds, causing many initial airline orders to be cancelled. Despite these setbacks, the development consortium held firm to its rigorous testing standards, ensuring the aircraft was as safe and reliable as they could possibly make it. In stark contrast, the Tupolev TU-144 program was conducted at a breakneck pace, driven by an unwavering political directive from the Soviet leadership: beat the West. Premier Nikita Khrushchev had famously demanded a supersonic transport, and the pressure to deliver it first was immense. This resulted in a compressed development timeline where design, construction, and testing phases overlapped significantly. The Paris Air Show is one of the world's most prestigious aviation events, a global stage where manufacturers showcase their latest achievements. In 1973, the undisputed stars were the 2 supersonic rivals, Concorde, TU-144. Both were present, offering a rare side-by-side comparison. The atmosphere was thick with Cold War tension and rivalry. Concorde performed first. A graceful, polished display, flown by seasoned test pilots, then the TU-144 flew. The Soviet crew, perhaps feeling pressure to outdo Concorde, flew a bike to a far more aggressive routine. The TU-144 was put through steep climbs, sharp turns, showing power and surprising agility. After a pass over the runway, it suddenly pitched into a violent climb. At the top, it seemed to stall, wings losing lift. It nosed over into a terrifying dive. The massive airframe broke apart in midair. Debris rained down on the village of Goussainville. The crash was a catastrophe. All 6 crew members aboard TU-144 were killed. 8 people on the ground were killed. Horrifying images were broadcast worldwide, staining the Soviet jet's image. The aftermath was a whirlwind of speculation and investigation. The official probe was hampered by Cold War secrecy. A definitive cause remains debated. One theory: pilots made an evasive move to avoid a French Mirage photographing the canards. That maneuver may have overstressed the airframe. Another theory: flight control modifications and a dropped camera may have temporarily jammed the controls. Regardless, the Paris crash devastated TU-144's credibility and cast a long shadow. For the USSR, triumph became a PR disaster. Concorde entered scheduled commercial service with a synchronized fanfare on January 21st, 1976. 2 flights departed simultaneously: British Airways, London to Bahrain Air France, Paris to Rio de Janeiro. Later that year, the premium routes opened: London to New York, JFK, Paris to New York, JFK. For the next 27 years, Concorde symbolized luxury air travel. A transatlantic flight took just under 3.5 hours, less than half the time of a conventional subsonic jet. The time saving drew high-level executives, celebrities, wealthy individuals. Life aboard Concorde was exclusive. The cabin was narrow, 2x2 seating. Service was first class all the way, gourmet meals on fine china. Vintage champagne. At 60,000 feet, passengers could see the curvature of the Earth. The Mach meter on the forward bulkhead let them watch, reaching Mach 2. Concorde was never a traditional moneymaker. Operating costs were enormous. Yet, it served as a halo product for British Airways and Air France. The TU-144's commercial story was brief and troubled. Passenger service began November 1st, 1977, single weekly Aeroflot flight Moscow. Alma-Ata, now Almaty. It was a domestic route, perhaps to avoid international scrutiny. From the outset, passengers reported excruciatingly noisy cabins, severe vibrations. The constant roar of afterburners' comfort was far below what Concorde offered. The TU-144's reliability was abysmal. Section 7. Public Perceptions. Icon of luxury versus enigmatic Concordski. In the public imagination of the West, Concorde became more than just an airplane. It was an icon, a celebrity in its own right. Its impossibly sleek and futuristic shape made it instantly recognizable and endlessly photogenic. The aircraft symbolized a glamorous jet-set lifestyle, a world of speed, style, and exclusivity. Speed, style, exclusivity. To see Concorde take off with its powerful engines roaring was a public event. To fly on it was the pinnacle of travel. It appeared in films, it was sung about in songs. It became a shorthand for progress and sophistication. This powerful and positive image was carefully cultivated by British Airways and Air France. Even the controversies, loud engine noise on takeoff and the sonic boom, could not tarnish its reputation. Environmental groups protested. Some communities banned it. For many, Concorde represented a magnificent human achievement. When the fleet was finally retired in 2003, the final flights were met with widespread public sadness and nostalgia. Crowds gathered at airports to witness the last landings, a testament to the deep emotional connection the public felt with this unique aircraft. It was mourned as the end of a beautiful dream. The public perception of the TU-144 was far more complex and shadowed. In the West, it was often derisively nicknamed Concordski, a name that implied it was little more than a crude copy of the Anglo-French design, likely built using stolen plans. The defining characteristic of both aircraft was their incredible speed. Concorde's typical cruising speed was Mach 2.04, or roughly 1,350 miles per hour, 2,180 kilometers per hour. This allowed it to traverse the Atlantic in under 3.5 hours. Racing the sun across the sky, flights from London, flights from Paris to New York would land at an earlier local time than they had departed. This ability to supercruise for hours on end without the continuous use of fuel-guzzling afterburners was the key to its operational viability. It flew at the edge of space, at an altitude of 55,000 to 60,000 feet, far above all other commercial traffic in most weather, ensuring a smooth and rapid journey for its passengers. The TU-144 was also a prodigiously fast machine. Its prototype became the first commercial transport to exceed Mach 2. The later TU-144D model, with more efficient engines, was certified to Mach 2.15. However, this raw speed masked a critical limitation in the early passenger models. The NK-144 engines required afterburners for the entire supersonic portion. This had a catastrophic effect on its fuel consumption and, consequently, its range. The TU-144 simply could not fly the long-haul intercontinental routes that were Concorde's bread and butter. It was a sprinter in a race that required a marathon runner. Both aircraft faced a fundamental, insurmountable obstacle: the sonic boom. When an aircraft flies faster than the speed of sound, it creates shock waves that travel to the ground and are heard as a loud, startling double boom. This noise is not a one-time event. It's a continuous carpet of sound laid down along the entire supersonic flight path. The public outcry over this noise pollution was immense. In response, governments around the world, including the United States, banned supersonic overland flight for commercial aircraft. This single restriction was devastating to the commercial case for both Concorde and the TU-144. This limitation meant that the potential market for supersonic travel was drastically reduced. The aircraft could only fly at their top speeds over oceans, or over vast, sparsely populated areas like Siberia. The dream of flying from New York to Los Angeles in 2 hours was dead before it began. This restriction, combined with high fuel consumption and operating costs, confined them to a tiny niche of premium transatlantic routes. The sonic boom problem proved to be an environmental and political barrier that even the most advanced engineering could not overcome, ultimately sealing the fate of first-generation supersonic passenger travel. For over 2 decades, Concorde boasted a perfect safety record, a remarkable achievement for such a complex and pioneering aircraft. Robust design, meticulous maintenance, high skill level of its flight crews. This unblemished record came to a tragic end on July 25, 2000. It ran over a small metal strip on the runway. The strip had fallen from another aircraft, a thrust reverser component from a Continental DC-10. The strip shredded one of Concorde's tires. A large piece of rubber was flung upwards at high speed. It struck the underside of the wing. The impact did not penetrate the wing, but it created a powerful shock wave within the full fuel tank. The tank ruptured from the inside, releasing a massive torrent of fuel. The fuel was ignited by sparks from damaged wiring or the heat of the engines. A huge fire erupted. The pilots lost control of the aircraft. The burning Concorde crashed into a hotel in the nearby town of Gonesse, killing all 109 people on board and 4 people on the ground. The accident shattered Concorde's image of invincibility and triggered an immediate grounding of the entire fleet. Following the crash, extensive safety modifications were made. Kevlar liners for fuel tanks, more robust burst-resistant tires. Concorde did return to service for a brief period, but the crash's psychological impact, a downturn in air travel following the September 11, 2001 attacks, and a final decision by Airbus to cease maintenance support, led British Airways and Air France to retire the fleet permanently in 2003. The single tragic accident proved to be the final blow for an aircraft already struggling with high operating costs. The TU-144 story was marked by safety failures from a much earlier stage. The 1973 Paris airshow crash had already crippled its international reputation before it ever carried a single passenger. A second fatal accident occurred on May 23, 1978, during a pre-delivery test flight of a new TU-144D model a fuel line ruptured in flight, leading to a fire that filled the cockpit with smoke. Section 10, Echoes of the Future, the enduring legacy of supersonic flight. Though neither Concorde nor the TU-144 flies today, their legacy continues to shape the world of aviation. They stand as monumental bookends to the first era of supersonic passenger travel, teaching invaluable lessons about both triumph and failure. They proved that the dream of routine Mach 2 flight was technologically possible. The research conducted for their development pushed the boundaries of aerodynamics, materials, science, engine, technology. Engineers today still draw upon the data and experience gained from these programs, particularly from Concorde's 27 years of successful sustained operations. It provided a real-world, long-term case study in the challenges of high-speed flight. Concorde remains a benchmark for engineering excellence and international collaboration. It demonstrated how a determined partnership, backed by rigorous testing and a refusal to cut corners, could tame an incredibly complex technological challenge. Its story is a source of inspiration, a reminder of a time when aviation was driven by bold, audacious goals. It lives on as a cultural icon, a symbol of beauty and speed that continues to capture the imagination. Museums that display the remaining Concorde aircraft draw huge crowds, a testament to its enduring appeal and the public's fascination with this singular achievement. The TU-144, on the other hand, serves as a powerful cautionary tale. Its story is a stark reminder of the dangers of allowing political ambition to override sound engineering judgment. The immense pressure to be first led to a rushed development that compromised safety and reliability, ultimately dooming the project.